Welcome back everyone. Today we are going to talk about IP address classes. IP address version 4 first address starts from 0.0.0.0 and it's end on 255.255.255 and 255. Each octet reaches to its maximum point, which is 255. How? If you do remember, in our previous lecture, we discussed that IP address is composed of 4 octets. So this is an octet, okay? An octet is composed of 8 bits and those 8 bits can be on and can be off. At the very starting point, all those 8 bits are off. And at the end point, all those 8 bits are on. Okay? So off bits is equal to 0, and when all the bits will be on, so it's equal to 255. So we have 8 on bits, that's why it's equal to 255. How it's equal to 255? You know, when it will be on, it will carry value like 1, 2, 4, 8, 16, 32 and so on up to 128. Okay, so that's why it can be the starting point is 0 and the end point is 255. Now come to this first octet. This first octet is further divided in sub ranges. In these sub ranges called classes. Called what? Called classes. So IP address version 4 have how many classes? There are 5 classes. There are 5 classes. These classes name A, B, C, D, E, not 1, 2, 3. Okay. So how many classes are there? 5 classes. Class A. So let's suppose classes. Class A, class B, C, D, E class. Okay, so as I mentioned before, this range is divided into sub ranges, like in 5 sub ranges. Okay, the first sub range start from 0 to 127. The second one is from 128 to 191, and the third one is from 192 to 223, 224 to 239, and then 240 to 255. Okay, so class A from 0 to 127, from 128 to 223, not 191. Class C 192 223. Class D 224 to 239. Class E 240 to 255. Okay, so see, from 0 to 255, and this from 0 to 255, this is the total range. Okay, and it's divided in these sub ranges which are assigned to each class. We can also find out this ranges from 0 to 127 up to and so on from the first 4 octet of this first, from the first 4 bits of the first octet. Okay, this is the first octet and the first 4 bits, this is the most significant bit. Okay, first 4 to class A. From those first 4 bits, 1 bit, okay, the first bit, and for class B the second bit, and for class C the third bit, and here the fourth one, and so on for the class E. Okay, this 0 is assigned for class A. Okay, and this 0 is assigned to class B. Okay, this 0, this 0, and this 0 for class C, and this 0 for class D. Okay, and for A all 4 bits are on. Now this is the most significant bit, as I mentioned before, the 0 1. What is the value of this? 128. So from 0 to 127. Okay, this second one is assigned to class B. The value of this is what? 64. So from 128 to 191 is equal to 64, and this is 32, and from 192 to 23 it's 32. Okay, and this one is 16. From 224 to 239 is equal to 16. Okay, so these were the first 4 bits of the first octet, which are used to identify each class. Next, we will discuss the default subnet mask. Default subnet mask. Class A default subnet mask is 255.0.0.0. Class B default subnet mask is 255.0.0.0. Class C 255.0. In class D, we don't have the combination of the prefix and suffix. Okay, so it is used for multicast, and they are multicast addresses. The class C is reserved. We don't know about this. Okay, it is used by internet society. Okay, so next, here you can see this first octet belongs to the prefix in the class A. The first 2 octets belongs to the prefix in class B. The first 3 octets belongs to the prefix. Okay, and here these 3 octets belongs to the suffix, and in class C only the last octet belongs to the suffix. Now next we will try to find out number of network bits in each class. Okay, remember, as we studied here, that 255, the first octet, belongs to class A. It doesn't mean that all the 8 bits belongs to class A. Remember, the first octet is shared. Okay, they shared among the all classes. So that's why we have to minus some of the bits from here. What bits we have to be minus? So these bits. Okay, first 2, and here 3, and here 4, like this. In class A, we have how many octets for the prefix 1? So that is equal to 8 bits, minus what? Minus this 0, 1 is equal to 7 bits. Class C, first 2 octets, so that's equal to 16, minus 2 is equal to 14. Class C, first 3 octets, that's equal to 24, minus 3 is equal to 21. So this is the actual amount of bits, okay, in each class: 7, 14, and 21. If you want to find out the number of networks in each class, so let's find out number of networks in each class. Like class A will provide us how many number of networks. Okay, so in order to find out number of networks, we use a formula. Okay, I will write the formula here. 2 power n is equal to number of networks. 2n mean number of network bits. So for class A, the formula should be what? 2 power 7 is equal to. For the class B, 2 power 14 is equal to. And for the class C, 2 power 21 is equal to. Okay. So here it is 128 and here it is 16,384. In here 2 power 21 is 2,97,152. Okay, so these are the number of networks in each class. Now let's find out the number of hosts in each class. Number of hosts in each network. For number of host finding, we use a formula 2 power h minus 2. Okay, so h mean number of host bits, okay, is equal to valid host. This 2 is the network and broadcast addresses. We have to minus them. Okay, network mean the very first in a range. Okay, the very first address, and here the very last address. Okay, we have to minus them. So now come here for class A, 2 power what? It's very simple. Come to this 1 2 3 octets, so 3 multiplied by 8 is equal to 24. For class B, 2 power 16. For class C, 2 power 8. How do I know 16? You can see 8 8 16 and 8. Okay, the number of suffix bits. Host bits mean the number of suffix bits. Okay, so 2 power 24 is equal to 16,777,216, and here 65,536, and here 256 minus 2 is equal to 254, and here 65,534, and here the last one will be 214. Okay, the rest is the same. So these are what? These are the number of hosts per network. Per network. Okay, if you want to find out the number of hosts in each class, then you should use this. Okay, number of hosts per class. So the formula is number of hosts multiplied by number of networks is equal to number of hosts in each class, like this. For example, for class A, what is the amount of hosts? That is 16,777,216 multiplied by 128. Okay, remember one thing very important in this 128, the 0 and 127 is reserve. Okay, but we are not talking about that right now. The 0 and the 126, the valid is 126 networks in class A. Okay, so is equal to the number of hosts in each class. For class B, not 16. For class B, what was the amount of hosts? It was 65,000. Okay, 65,536 multiplied by the number of networks. Where is the number of networks? 16384. Where is the 16384? In class C, 256 multiplied by the number of networks is huge here, 2097 156. I think, let me make sure. Yes, it's 152. Okay, so equal to what? The number of hosts in each class. Okay, let me use calculator for this purpose. Okay, so this is the total number of hosts in class A. In class B, the total number of hosts is in class C, the total number of hosts is 256 multiplied by 297152 is equal to 192. Okay, so these are the total number of hosts in each class. If you want to find out the total number of addresses in class A, the formula is you are required to 2 power 32 is equal to, it's almost 4 billion. Okay, 2 power 32. 4294967 This is the total number of IP addresses in class C. Okay, I hope now the things are clear. So we covered many fundamental concepts and topics here. Okay, inshallah, in our next lecture we will have discussion about private and public IP addresses and many more things like net, etc. in our lecture, and onward we will start subnetting chapter. Okay, thank you very much. See you in the next lecture.